Good afternoon, guys. And today our topic is measurement and instrumentation. This is EE402, and we are going to discuss on the transducer. Okay, so what is the transducer? Look, first there is a two section is there. One is transducer, and another is your sensor. So there is a two simultaneous instruments is there. One is a sensor, and second one is transducer. One is this is transducer. T, transducer. Second one is sensor. So this is just like a coin. This is the one side of coin, and this is the another side of the coin. So what is a sensor? Sensor is a device which can just sense any physical phenomenon. Any physical phenomenon means, say, this is the temperature. It may be flow of water. It may be a flow rate of water or any fluids. Its humidity, etc. So this is the physical quantity, or this is the physical phenomenon and occurred in our environment. We have to measure it. It means blow rate of wind. This is the things. And these things are first sensed by one device, which is called sensor. And if we use then sensor is just sense it, but we need to measure it. Then obviously we need an electrical signal. Say this is any physical quantity. Say this is heat or the temperature. We need to measure it. Then we use some thermometer, any type of thermometer. But for our controlling purpose, measurement instrument, we need to measure it. So we need to make it as a signal. So this first sensor is, say, this is the RTD. This is RTD. You will read this word RTD. TC means thermocouple resistance temperature detector. This is RTD. TC. It will just sense the temperature, means it will produce some electrical signal. Okay. Then this electrical signal will measured by some device. This is it may be op amp. Then it is device we can see in our digital display board or visual display board, VDU, or you make so this is the digital display unit board. So in this way we can measure some physical phenomenon which happens in our environment and which is required. Then it may be this signal may be sent to the controller. This signal may be sent to the controller so that it can control the temperature. It can control the flow rate of fuel, anything as it is directed. So this is the instrumentation scheme for measurement of any physical phenomenon. So you can see there is two things are required. First one is sensor, second one is transducer. So first sensor just sense the physical phenomenon, and transducer is a device is which can convert any physical phenomenon into a electrical signal. Okay, without electrical signal, the controller can read, or the measuring device, just as digital instrument or the analog instrument, analog electronics or electrical instrument, would not sense the physical phenomenon. Then it should given some electrical signal. So that is the scheme of instrumentation for the measurement purpose. And today our topic is LVDT, linear variable differential transformer. So it is a transducer. Okay. So sensor only sense it, and transducer, it is used just this is a just like a coin. One side coin is sensor, another side of this coin is transducer. Sometimes it this is coming in a single device, and sometimes we need some separate, so separately. And this is the transducer we are going for. Transducer means, and transducer is a device which can convert any physical phenomenon into a electrical quantity. Say in this topic we are going to discuss about the LVDT. LVDT. LVDT stands for linear variable differential transformer. So what I'll do, it is just measure the displacement. Look, displacement. If there is any displacement, you can see there is some displacement board. Yes, some millimeter range displacement it will measure. And so if it is coming here, it may be positive. If it's going here, it may be negative, and it is just coming to the scale over here, then it is going 0. This is the actual purpose of this LVDT. This is measuring the linear displacement only. And now we have to know what, how, and why. Means whenever you get this LVDT, then you may ask what what is LVDT, and how means application, how it is working, and then why means where it is applied, means what is the application. So in this way we can learn a device or a system very easily. And one more thing, there is a division of the transducer: primary transducer, or the primary transducer, secondary transducer, okay, active transducer, passive transducer. Look, which one is the active? One more thing, active transducer, passive transducer. Look, active and passive, and primary transducer, primary and secondary. Secondary. Look, the transducer which has the ability to produce the electrical signal from itself, it is called the active transducer. And the transducer which needs some power externally to operate, then it is called the passive transducer. I am going to the example, the TC, thermocouple. Thermocouple is producing millivolt range output. If we apply some heat, or if apply some heat or the temperature difference, then it will produce some millivolt. So it itself produce some electricity, the signal which is measurable quantity, then it is called the active. And the piezoelectric piezoelectric device is piezoelectric crystal. It is also producing some millivolt range output. That is also a active, because it itself produces some electricity for a measurable quantity. But other transducer, just like LVDT and any other, it needs power. Look, here some wire is there. We have to apply some power externally. Otherwise, it will not working. Then it is called the passive transducer. So transducer are categorized in two ways. First one is active, second one is passive. Okay. And now it is coming to the primary transducer. Some transducer are there which could not produce electrical measurable quantity is signal. Okay, it's converts some physical quantity physical quantity into some physical measurable quantity. able quantity. And now then another transducer is required to make this physical measurable to electrical quantity. Then this transducer is called secondary and this is the primary. Okay, we are going to we are going for the example. Just pressure measurement device. That this is a boron tube. This is a boron tube. It is just measuring the air pressure or the fluid pressure converted into another scale division, that is also a physical quantity, not any electrical quantity. Okay, but if we add some LVDT, that is LVDT, then it will produce some electrical quantity. So this is the secondary transducer. So there is the two type of transducer is there. First one is primary transducer, second one is the secondary transducer. So first, primary transducer only convert any physical phenomenon into a physical quantity for measurement purpose, just like scale or analog indication. And the secondary transducer is a device which can convert any physical phenomenon or physical measurable quantity into a electrical measurable quantity or electrical signal, rather you can say. Then it is called the secondary transducer. Now we are going for the LVDT. LVDT stands for linear variable differential transducer. Now we are going for the construction, working principle, and then application. First one is construction. You can see there is a primary winding, there is a secondary winding, and there is a some displacement. This is the core and this is the plunger displacement. And if we go for sharing, look, the construction and working principle first. Look, this is the LVDT. LVDT consists of generally two coil. First one is the primary coil. This is the primary coil. Just look like this, primary coil. And second one is the secondary coil. As it is a transformer, then it comprises of primary and secondary coil. Okay. This is the secondary coil. And this is the primary coil. We have to we have to give some external power, that is always AC. Then there is a core. Core is just like this. Core is just like this. This is the primary. This is secondary 1 and this is the secondary 2. Look, whenever core is just at this position, then from the primary to secondary there is induction, and in S1 there is no induction is there because there is no core is there, and so there is no induction is there. So the only core position will decide, whereas the S1 or S2 or S1 and S2 both are induced. So if I push this plunger or create some force so that this core should displace, then core achieves some different position. Say this is the position 1, this is position 2, this is position 3. So what happens when it is coming? This is a primary. When this is core is at the position 1, this is position 1, then what happens? Look, this is secondary 1, this is secondary 2. Only the secondary values, only the secondary 1 can induced. Only secondary 1 can induced. So in this way we can say that only S1 is E1, S1 is EMF induced is E1, and S2 EMF induced is 2. So output is U1 minus E2. So whenever plunger coming at the position, so in this position it is E1. So now E2 is 0. So output for this case 1, for case 1, E output equal to U1 minus E2. Now E2 is 0, so only E1 is the output value. Now for the case 2, position case 2, in this case you can see this is the primary and this is core is at the middle, and the secondary, both of the secondary are getting this core. So EMF induced in both E1 and EMF induced in both E2 are same. So E output is E1 minus E2. So this is 0. This is 0 because same secondary are getting in EMF, induced EMF is same quantity. So it will produce 0, means it is the 0 position. And for the case 2, case 3, case 3, if this is coming, this code is coming at the front of secondary 2, secondary 2, this is secondary 2, this is secondary 1. So at that moment only secondary 2 is getting induced, and S1 is just free, it couldn't be induced. So E output is E1 minus E2. Here E1 is 0, so it is coming E2. So E output is just E2. This way we can get some value, electrical value of the changing or variable position. Okay, when this is here, then we get some positive value. When this is at the between, then it is given 0. When it is at the S2, then it is given only minus value. And in between this position, you can get any value where we can calibrate it to decide some scale position. So the movement or displacement is just as limited to some millimeter value. Generally, it is going to 16 millimeter, but for the measurable linearity, we are generally measured 10 millimeter differentiation. Means 10 millimeter we can measure this. So this is the working principle. And for the construction, you can see there is a primary coil, there is a secondary coil. In between this primary and secondary, there is a hollow type core is there. Whenever core is position is measured by the electrical quantity. Core position means where my object, here object is there. We apply some object is there. Object is there. This object position is decided by this electrical quantity we can measure. And now this is given the AC signal or the AC power, and we know this AC is not generally 50 hertz. This is 1 to 4 kilohertz. Okay, then it will induction rate will change and it is became so high. This is the LVDT. And now where is the application? Application, look, Uh, LVDT is generally applied for the measurement of the displacement, and this is applied. Say this is a rolling mill. Rolling means there some rollers are there. Some rollers are there. This is the roller. This is the fixed, and upper can just coming up and down, but in very small range, generally 20 millimeter range. Okay, so that it can control the thickness. Say some in a conveyor belt, there some materials are going there, and in this case, we get some we get some specific thickness value. Say it may be biscuit factory. There you can see in biscuit production factory, you can see there are some uh, dough like dough are just pressed in, so that the thickness of the biscuit should should maintain. It may be paper mill, paper pulp. We need to control the GS thickness of a paper. Then we can control the paper. It may be thickness of any metal sheet, so that we can control the thickness of this metal. Then we need to control this roller. If this roller position is gap is very high, then it will produce the thick sheet, thick paper. If the roller gap between these two roller is very small, then it will produce very thin amount of paper, or thin amount of your metal sheet. So this gap will measured by this LVDT. This LVDT. Say we put some LVDT here. So the plunger of LVDT attached with this core, and it is attached with here, and we can measure secondary. We can measure this quantity because LVDT is there. LVDT. If this thickness is too high, it will produce is high thickness. It is showing that. If the thickness is very low, then it will say some position which is very low position. Then controller will decide which position we require. Another portion, say I need to measure some displacement. Say displacement in some millimeter range, some few millimeter range, generally uh, 16 to 18 millimeter range. We can use this LVDT because LVDT can show which is the core position. Output is showing which one is the core position. Maybe it is 0. This is the 0 position. This is the negative position. This is the positive. Say this is the positive 5 millimeter. This is negative 5 millimeter. So as per the displacement of this plunger, LVDT can show which position it is. It is at uh, now. At now it is present. In this way, we can use LVDT, linear variable differential transformer, to measure the linear displacement. This is the main topic for the LVDT. Now, if we some plot some range, just want to share this. Look, in this position we can get. Look, if we plot some graph position, then we get some linearity. This is the linearity. LVDT AC output magnitude over here means some voltage is given over here, and this is generally working position is 1.4 volt. Okay, and this is 100% different, 100%, and displacement. This is generally 16 to 18 millimeter, but our working range we are applying, this is the 10 millimeter, means 5 millimeter are in this side, 5 millimeter in this side. So we are getting this voltage, that is 1.4 volt, and in this way we can measure any displacement among the 5 to 0 to 10 millimeter range by using this LVDT. Okay, this is the graph. And now how this is actually it will measure the displacement by this LVDT, and this measuring quantity, this is say this is primary, and this is the secondary. In primary we are getting some uh, 1 to 4 kilohertz AC signals, and then as per the secondary it will get some output. This output will amplified and it will compared with this B. B means the input and output A by B, and then it will going for the filter, then op amp, then it will produce some output, and this output is given to the display unit so that we can see the displacement, and it may be sent to the controller so that controller can control the position as per requirement. So this is LVDT, linear variable differential transducer. Now there is another position, another type of variable displacement measurement, that is RVDT. RVDT nothing but a device like LVDT, but it is measuring the rotational part, or you may say this is angular portion, angular movement. Say this is uh, if I draw this, then you can understand. Okay, RVDT, if we say this is the RVDT, this is the core, and if there is a primary coil is there is the primary coil, and here is the secondary coil is there, say another secondary coil is there, this is the output, and core is just like this. Core is also a angular or rotative or rotational, just like core. So this is the angular movement. Say if it is going to inward, then it will get the secondary, but it will not get the primary. If it coming outside, then it will get the primary, not getting the secondary. In this way, we can measure the angular displacement, and that is for a rotative variable differential. This is called rotative variable and differential transformer. So this RVDT is also behaves like in construction wise just same with the LVDT. RVDT is just rotational movement, measure the rotational movement or the rotational displacement, and LVDT measure the linear displacement. This is the difference only, but others working principle just like same. Okay. Uh, Guys, if you have any question, you may ask me. Okay, strain gauge will cover on the next day. Okay, thank you. I'm going to close there. If you have any question, you may ask me. Okay, thank you.